In this video, I'm going to show you how to multiply binomial expressions with other binomial expressions. We're going to do this with both polynomials and also radical expressions. So let's go ahead and take a look at this. So for this first example, we're asked to simplify the quantity 2x plus 3 times x plus 4. So I'm going to show you two different methods. The first method I'm going to show you is using the distributive property, and then the second method is using this box. So let's go ahead and use the distributive property. So in order to use the distributive property, basically what we're going to do is we're going to take this first binomial and distribute it through to our second binomial. So to do that, I'm going to have to take this first term in our binomial and multiply that entire second binomial by it. So we're going to take the 2x and I'm going to multiply x plus 4 by 2x. Then we're secondly going to take this positive 3 and do the same thing, multiply it through to x plus 4. So it's going to be plus 3 times the quantity x plus 4. So then you just go through and do your multiplication. So in multiplying, it's 2x times x. So remember, this x has an implied 1 here. So 2 times 1 is 2. And then this is x to the first and x to the first. So when you multiply powers to the same base, you add their exponents. So we're going to end up with x squared. And then the 2x times 4, 2 times 4 is going to be 8. And then it's just going to be x. And then we take the 3. So we're done now with that term, right? And now we're taking the 3 and distributing through. So 3 times x, that's going to be 3x. And then 3 times 4, that's going to be 12. And then to finish it up, we're going to combine any like terms. So 2x squared doesn't have any like terms, so it's going to stay 2x squared. The 8x and 3x, those can add because they have the same variable composition. So you just add the coefficients. 8 plus 3, that's 11, so plus 11x. And then this constant is all by itself there. So that's the distributive property method. So let's take a look at how we can use this box to help us when doing this multiplication. So when doing this multiplication here, basically you're going to take each binomial and put it in part of your box. So I'm going to take this first binomial and put it down across these rows. So it's going to be a 2x here and then plus 3 there. And then the x plus 4 I'll put along the columns up here. And then you're going to multiply. So this is kind of like a Punnett square that you would see in science. And then each square is going to be the comprised of the product of the particular parts. So this first box is going to be 2x times x. So that's 2x squared. The second box is going to be the product of 2x and 4. So 2x times 4, that's going to be 8x. Then this box here is going to be the product of 3 and x. So that's 3x. And then this box is going to be the product of 3 and 4. So since they're both positive, it will be 12. And then all of these are individual terms, and you combine them to make your polynomial. So 2x squared doesn't have any like terms, so it's going to stay. We notice that along this diagonal here, we have 8x and 3x. So those can combine to be 11x. And then the constant is, again, all by itself. And you notice that what we get is the same result as doing the distributive property method. So both of these are equally effective, and it's all just a matter of personal preference. So I'm going to switch back and forth between the methods that I use in this video, just so that you have an opportunity to get more comfortable with both of them. So let's take a look at this next example. So this next example is asking me to simplify this radical expression, the two-term radical expression, times this other two-term radical expression. So for this example, I'm going to use the distributive property method. So we're going to take the square root of 2 and I'm going to multiply it through to both terms in my second radical expression. So square root of 2 times square root of 3. Remember, when you're multiplying radical expressions, you multiply the numbers that are on the outside and then you multiply the numbers that are on the inside. Both of these have an implied 1 on the outside. So 1 times 1 is 1. And then on the inside, 2 times 3, that's 6. So we're going to have the square root of 6. Remember, to multiply radicals, they need to have the same index. And these are both index of 2. Okay, so now the square root of 2 times 2. So this 2 just multiplies the implied 1 that's on the outside. So it's going to be plus 2 times the square root of 2. So now we're done with this term. We've distributed it through to all of the other terms in the binomial. So we're going to take the negative 1 now and distribute it through to the other terms. So negative 1 times square root of 3. That negative 1 multiplies the implied 1 there. So it's going to be negative 1 times the square root of 3. And then the negative 1 times 2, that's just going to be negative 2. Now remember, when you're combining your radicals, in order to do that, you need like radicals. And in order for them to be like radicals, they have to have the same index, which all of these do. Those are all index of 2. But they also have to have the same radicand, the same thing inside our radical, which none of those do. So we actually can't combine any of these, and this would be it simplified. We basically, by expanding it, simplified this binomial expression. So let's try this one using the box method. So I'm going to put this first radical expression here along the side like this. So we have our 2 rad 2 and our negative 3, and then 3 rad 2 and our positive 1. So let's multiply. So the 2 times 2, that's going to, or sorry, 2 times 3, that's 6. The square root of 2 times the square root of 2, that's going to be the square root of 4. 2 times positive 1 is positive 2, and then the rad 2 kind of just tags along for the ride. A negative 3 times a positive 3, that's negative 9, and then again a rad 2. Negative 3 times positive 1, that's negative 3. Now, do we have any like radicals? So we need to try and simplify this. The 6 rad 4 doesn't. Square root of 4 is actually just 2, right? So this is really kind of like 6 times 2. 6 times 2, that's 12. These two are like radicals. They have the same index and the same radicand. So we just take the numbers in front and we use their operations as they are. So negative 9 plus 2, that's going to be negative 7. And then the rad 2 just kind of tags along. And then minus 3. And then we can simplify this because we have the 12 and the minus 3. So 12 minus 3 is 9. So it's going to be 9 minus 7 rad 2. So this would be, that's our final result. So this would be simplifying this using the box method. Now, what if we wanted to multiply a binomial into a trinomial? What changes? Honestly, not a whole lot. So you could use distributive property. If you use distributive property, you would take the 2x and you'd have to multiply it through to all 3 terms. And then you would take the negative 3 and multiply it through to all 3 terms. Now, if you're using the box method, you'd have to add either an extra column or an extra row and go through like this. And then, so in this case, we would end up putting our trinomial here, right? Like this. And our binomial here. And then we would just multiply through. So I'm going to do the distributive property first. So let's go ahead and do that. So 2x times 4x squared. So 2 times 4, that's 8. X times x squared. So that's x to the first and x squared. So you add the exponents. So you get x to the third. 2x times x. So 2 times 1 is 2. X and x is going to be x squared. And then 2x and negative 6. So 2 times negative 6 is negative 12. And then it's just going to be x to the first. Then we can take the negative 3 and distribute it through. So negative 3 times 4 x squared. So negative 3 times 4 is negative 12. And then we're going to get x squared. And I'm going to line up the terms for the second one with by degree. So we can just do some like vertical adding. So that's going to be negative 12x squared. And then negative 3 times x, so that's just going to be negative 3x. And then negative 3, so right. And then negative 3 times negative 6. A negative times a negative is positive. And then we can just add these. So adding straight down, 8x cubed. It has no like terms, so it's going to just stay 8x cubed. 2x squared and negative 12x squared. So 2 minus 12, that's negative 10. And then the x squared stay the same. These have the same sign, so you add their values and take their sign. So it's going to be a negative, and then 12 and 3 is 15, x, and then plus 18. So if we were to go through and do this, here again, it would just be this times this gives us this times this gives us this times this gives us that. And we'd end up with, if you went through and did it, you'd notice we get so this part here mirrors what we have by distributing the 2x through first, and then the bottom is going to mirror what we would get by distributing that second term through. And then when we combine all of this, we would end up with the same result. So it's pretty nice to have those two different methods to be able to do this simplifying. All right, so let's look at an application of this kind of problem. So in this problem, we are being asked to find the area of the shaded region. So the shaded region is this part here in red. Now, if I want to find the area of this shaded region, it's basically the area of like this rectangle here, right? This rectangle here that we have, minus that part that's cut out, minus this part here. So basically we're just cutting out this hole in this rectangle. So how should we approach this? So basically it's going to be looking at the area of the big rectangle minus that area of the little rectangle. So the area of the shaded region is going to be equal to the area of the total region minus the area of that hole that's cut out. So to find the area of the shaded region, we need to first figure out what's the total area, what's the area of the hole, and then take their difference. So if I want to find this big area, the area of the full circle, so let's say looking at the total, well, that can just be represented by the area of this rectangle. And we know the area of a rectangle is length times width, so we can just do that product. So let's actually find this area. So 2x times 3x, that's going to be 6x squared. 2x times 1, that's 2x. So that's the first term. Taking the second term and multiplying it through. So 5 times 3x, that's 15x. And then 5 times 1 is 5. Combining our like terms, we're going to get 6x squared. It has no like terms. The 2x and the 15x are like terms, giving us 17x and 5. So that's the total area, the area of the full rectangle. Now, what if we wanted just the area of this inside part? Because we know we need to subtract this hole from that total area. So the area of the hole is length times width. So again, it's x times x plus 2. We can just do distributive property on this one. So x times x is x squared. X times 2 is a positive 2x. And we need to take this expression and subtract x squared plus 2x from it. So let's go ahead and do that. So I'm going to take this here and subtract this from it. So we have now this expression, right? So we're taking that first area and we're subtracting that second area. Now, if you remember from when we did subtraction of polynomials, we have to make sure that this negative distributes through to all of those terms. So I'm going to make this positive and distribute it through to this and make these negative. So essentially what we end up with, right, is something like this here, where now this is negative, this is negative, because we distributed the negative through, and we can now just combine our like terms. So what is 6x squared minus x squared? Well, that's going to be 5x squared, right, because this has an implied 1 out in front. 17x and minus 2x combined to be positive 15x, and then 5 is all by itself. There's no like terms with it, so we end up with this. 5x squared plus 15x plus 5. So that would be how you'd find the area of the shaded region. You just find that total area of this whole thing and then subtract the area that's cut out, right? That area, that hole. And you would do that by using the area of a rectangle's length times width and then length times width and subtracting them.